Now I didn't write out the instructions here just to save space so I can get all these problems worked out on one screen, but I'll read them to you here. Calculate probabilities of simple and compound events, and or and not, and conditional probabilities. Be able to decide when events are independent and mutually exclusive. There will typically be a problem in which information is presented in a table asking for various probabilities. For example, a previous exam question dealt with a book binding color and nationalities of authors. So here we have book binding colors, red, blue, and brown, and nationality of authors, English, French, German, and Russian. All right, part A wants us to find the probability that the book has a red binding. All right, the probability that the book has a red binding, what we're going to do is we're going to look at the total number of books that have red bindings. Oops. The total number of books that have red bindings, and we're going to divide that by the total number of books altogether. So this is going to be 21 over 95, or approximately, 21 divided by 95 is 0.221. And it's pretty standard to use 3 decimal places for most probabilities, and that's fine. B, they want the probability that the book is written by a Russian author and has a brown binding. So the probability of Russian and brown binding. Well, in order to get this, what we need to do is we need to find out how many Russian authors there were that had books with brown bindings. So for an and probability on a contingency table like this, this is actually pretty simple. We just have to look to where the 2 columns intersect each other. So Russian and brown, there are 6 of those books out of the total of 95. So 6 over 95, and that's approximately 0.063. All right, part C. The probability that the book has a red binding or a French author. So let me bring this one down here. So the probability of a red binding or a French author. Now, according to our rule set here, the probability of a red book binding or a French author is the probability of the first event, probability the book is red, plus the probability of the second event, French author, minus the probability of them happening together. So red and French. Now, the reason that we have to do it this way is because when we go to calculate the probability that the book has a red binding, there's 21 of those. The probability that the book is written by a French author, there's 32 of those. But in order to get 32, we add up 11 plus 7 plus 14. In order to get 21, we add up 4 plus 11 plus 6 plus 0. So this 11 gets counted 2 times. So we're doing 21 over 95 plus 32 over 95 minus 11 over 95. So that 11 that gets counted twice, we just kind of take it out of the total one time. All right, so that gives us then, let's see, that would be 21 plus 32 minus 11. That's 42, and that's divided by 95. So 42 over 95 is about 0.442. Okay, part D. The probability that the book is not written by a German. Well, there's always more than one way to come up with a not probability. If it's not German, the author, then we could just add up all the English, French, and Russian authors. That would be fine. Another way is to do 1 minus the complement of the event, so the 1 minus the probability that the author is German. And that would give us the same result. This would be 1 minus 16 over 95, which would be, so 1 minus 16 over 95, so we get 0.832 when we round properly. Part E, the binding is not blue. Same concept here, 1 minus the probability that the binding is blue. So we would do 1 minus, there's 25 out of 95 blue bindings. So 1 minus 25 over 95 is 0.736. Sorry, 737 when I round properly. Part F. The probability if the book is by an English author given it has a brown binding. So by an English author given it has a brown binding. Alright, remember this bar represents the words given that. So the probability that the book is by an English author given that it has a brown binding. So the part we say given that after, that's the part that we know. So we know the book has a brown binding, so we restrict ourselves to that part of the table, just the books that have brown bindings. Alright, now restricting ourselves to that part of the table, there are 21 of them by English authors out of the total of 49. So this is going to be 21 over 49, or if we change that to a decimal, .429. Then part G, the probability that, or assuming the book is by a German author, probability it has a blue binding. So probability of a blue binding given that it's by a German author. Okay, so we know that the book is by a German author, so we're going to restrict ourselves to books, just by German authors here. So this set right here. And the probability that the binding is blue. There's 2 blue binding books here by German authors out of 16 total books. So 2 out of 16. And we can approximate that with 0.125.